And last question. First one will have the slope of 3, 2 and 5, 3. And we'll also have the slope of 1, 4 and 2, 2. To determine if these lines are parallel, perpendicular, or neither, we'll first have to find the slope of the first points and also find the slope of the second points. If we find the slope of the first 2 points, again we'll have a fraction. We'll subtract the second y value from the first y value, which is 3 minus 2. And we'll also subtract the second x value from the first x value, 5 minus 3. 3 minus 2 would be 1, and 5 minus 3 would be 2. So the slope from the first 2 points is 1/2. Next we'll find the slope of the second 2 points. And once we find the slope, then we'll compare them to see if it's parallel, perpendicular, or neither. Subtracting the 2y values, 2 minus 4, and subtracting the 2x values, 2 minus 1. 2 minus 4 is negative 2, and 2 minus 1 would be 1. So the slope of the first 2 points is 1/2 or 1/2. Slope of the second 2 points is negative 2/1 or negative 2. These are not parallel since they're not the same. To be perpendicular, they have to be opposites. One is positive, one is negative, so they're opposites. The reciprocal would be the same fraction flipped upside down. 1/2 is the reciprocal of 2/1. So these points would be perpendicular. Title of the first section today is Find an Equation with a slope and a point. So in this section we'll find an equation for a line using a given slope and a given point. First problem, the point is negative 4, 1, and the slope m is equal to negative 3/2. If you remember graphing lines or equations of lines, the form is y equals mx plus b. Using the given information, we have a x and y point we can plug in for x and y. We have a slope m we can plug in for m, and we can find the missing value for b. So in place of y, we'll use the y value, which is 1. Instead of m, we'll use the slope, negative 3/2. Instead of x, we'll use the number negative 4. And plus b, we'll find b to use for our final answer. To solve this one, negative 3/2 times negative 4. You can make negative 4 a fraction by putting a 1 on the bottom. So we'll have 1 equals negative 3 times negative 4 would be 12, and 2 times 1 would be 2. Simplifying, 12 divided by 2 would be 6. So we have 1 equals 6 plus b. Solving for b, we can subtract 6 on both sides. 1 minus 6 would be negative 5. So negative 5 is equal to b. Keep in mind the question is to find an equation. What we'll use is this top equation, y equals mx plus b. So our answer will be y equals m, which the original slope was given, negative 3 over 2, and we'll leave x and y in the equation, and instead of b, we'll use the value minus 5. So the equation of the line would be y equals negative 3 halves x minus 5. Title of the next section is Find an Equation. With 2 points. So in this section we want the answer to be an equation, and we'll be given 2 points to find that equation. First problem. 2 points. The first point is negative 1 comma 4 and negative 4 comma 5. So using these 2 points, we can write an equation in y equals mx plus b form. The first step, we can find out the slope, or what m is, using the 2 points. If you remember from the previous section that we did, y2 minus y1 over x2 minus x1 is the equation for a slope. If we subtract the y values, we'll have 5 minus 4, and the x values, negative 4 minus a negative 1. 5 minus 4 would be 1, and negative 4 minus a minus 1 would be the same as negative 4 plus 1, which would be negative 3. So our slope would be negative 1/3. Once we have the slope m, then we can use the equation y equals mx plus b to find out what b is, or find the y-intercept. Just like in the previous section, we'll plug in numbers for x and y. Since we have 2 points, we can use either point to get the correct answer. For example, we can use the first point. The y value would be 4. The m we found was negative 1/3. X is negative 1, and plus b. If you wanted to, instead of negative 1 and 4, you could use negative 4 and 5, and you get the same answer. Solving from here, 4 equals negative 1/3 times negative 1 would be positive 1/3 plus b. Solving for b, you can subtract 1/3 on both sides. 4 minus 1/3 would be 3 and 2/3. So b equals 3 and 2/3, or as a improper fraction, 3 times 3 would be 9, plus 2 more would be 11. 11 over 3. So our final answer, y equals, the m that we found in the question was negative 1/3 x, and the b value, we could use either one. You could have plus 11 over 3. So the final answer, y equals negative 1/3 x plus 11 over 3. Title of the last section today is Finding a parallel or perpendicular equation. So this section will still find an equation of a line, but we'll find either a parallel equation or perpendicular equation. First question is -3, comma, -1, and parallel to y equals -x plus 5. So we want to find an equation that's parallel to this equation, but passes through the point -3, -1. We can find the slope for a parallel line. If you remember the definitions we did in the previous section, a parallel line has the same slope. The slope of this equation, in terms of y equals mx plus b, m, or the slope, is a number in front of x, which is -1, so the parallel slope would still be -1. And again, we can use the equation y equals mx plus b. Using the slope we found and the point, we can find the new y-intercept, or the new value for b. Y is -1 equals, m is also -1, x is -3, and plus b. Multiplying -1 times -3 would be 3 plus b. Solving, you can subtract, and b is equal to -4. The answer to the question again will be an equation. Y equals, the m is -1, so -1x, and the b value we found was -4. So the equation y equals -x minus 4 would be the answer. Second question, and last question for the section. We'll have the point 6, comma, -5, and perpendicular to 3x minus 1 over 5y equals 3. So again, this time we want an equation that passes through this point and is perpendicular to the equation. This equation is not in y equals mx plus b or slope-intercept form. So to find the slope, we have to first put it in slope-intercept form. To do that, we can subtract 3x on both sides. So we'll have -1 over 5y equals, putting x first, we'll have -3x and plus 3. To get rid of the fraction -1/5, you can multiply by the reciprocal, which would be -5 over 1, and we'll multiply both sides by -5 over 1. The reciprocals cancel out, so y equals, distribute the -5, -5 times -3 would be 15x, and -5 times a positive 3 would be -15. So the equation given in the problem in slope-intercept form is 15x minus 15. We want the perpendicular slope to this equation. So the perpendicular slope, if you remember the definition, is opposite reciprocal. The slope here is 15 over 1. Opposite would be negative. And the reciprocal of 15 over 1 would be 1 over 15. So the slope that we'll use for our answer is -1 over 15. Continuing the question, to find b, we'll use the original point, which was 6, comma, -5. So the y value is -5 equals m, which we found was negative 1 over 15, times x, which is 6, and plus b. Solving the equation, negative 5. Negative 1 over 15 times 6 over 1 would be negative 6 over 15 plus b. And solving for b, we can add 6 over 15 on both sides. Negative 5 plus 6 over 15. We need common denominators for those. So we can make it negative 5 over 1. And the common denominator would be 15. So negative 5 will multiply by 15 for the numerator and denominator. 15 times negative 5 would be negative 75 over 15. And we're adding to that 6 over 15. Subtracting negative 75 over 15 plus 6 over 15 would be negative 69 over 15. Keep in mind to always reduce fractions. 69 over 15, you can divide each of those by 3. So we'll be left with negative 23 over 5 for the b value. The final answer, y equals. The slope we found was negative 1 over 15x and minus 23 over 5. Title of the first section today is Graph, Absolute Value, Equations. In this section we'll graph absolute value equations on a xy axis. The first equation is f of x, or f parentheses x, equals the absolute value of x. To graph absolute values the first time, we'll make a t-table with t-values. Using the x values, you can use any values that you want. The best ones to use for this case will be negative 1, 0, and 1. Plugging the numbers in for x, we can find out what the value of y is, or is also the same as the function of x. The absolute value of negative 1 would be positive 1. The absolute value of 0 would be 0. And the absolute value of 1 would be 1. Graphing these points on a xy axis. Negative 1, positive 1. 0, 0, and 1, 1. The 3 points line up to make a V shape. We will connect them to make a V shape. Every absolute value equation that we graph will be a V shape. And this will be the graph for the question. Second question and last question for the section. G of x, or g with x inside parentheses, is 3 times the absolute value of x. So in this problem we'll take the absolute value and then multiply by 3. Same steps, we'll do a t-table, xy t-chart. Again, you can use different values for x, but the best ones to use for these problems will be negative 1, 0, and 1. Plugging a negative 1 in, the absolute value of negative 1 is positive 1. Positive 1 times 3 would be 3. Absolute value of 0 would be 0. 0 times 3 would still be 0. And the absolute value of 1 is 1 times 3 would be 3. Graphing the points again on the xy axis. Negative 1, 3. 0, 0. And 1, 3. And again, the points should line up to make a V shape. Every absolute value graph will be a V shape. We'll connect them, and that will be the graph for the equation. Title of the last section of notes for today is More Absolute Value Equations. In this section, we'll continue to graph absolute value equations. First question is f of x equals the absolute value of x minus 2. For these graphs, we'll graph using a xy axis, but we'll be able to graph without using a t-chart. To graph absolute value equations without a t-chart, what we'll do is take what's inside the absolute value, in this case x minus 2, and we'll set that equal to 0. The reason we set it equal to 0 is this will be the smallest value, or sometimes the biggest value that the absolute value can be. So x minus 2 equals 0. If you add 2 to both sides, we'll have x equals 2. For this, we can do a t-chart, but instead of doing 3 points or multiple points, we'll do just a single point at x equals 2. Plugging 2 into the original equation, 2 minus 2 would be 0. The absolute value would still be 0. Drawing the xy axis graph, we can graph this function with a single point. The point is 2, 0. From the previous section, absolute values again are V-shapes. Normally the V-shapes will open upwards. Sometimes they will open downwards. To determine which way it opens, look at the number in front of the absolute value. In this case, there is no number, or there's a coefficient of 1. If it's a positive number like positive 1, the absolute value would open up. And that would be the graph for the function. Second equation we'll graph. G of x equals inside the absolute value x and outside the absolute value minus 3. Again, to graph these using just a single point, we'll take what's inside the absolute value. In this case, it's just x, and we'll set that equal to 0. This equation is already solved, x equals 0. So again, we'll do a t-table with just a single point using the value x equals 0. Plugging a 0 in, the absolute value of 0 would be 0, and minus 3 would be negative 3. Drawing the xy axis, we can graph just the single point, 0, negative 3. Again, to determine which way the absolute value opens, the number in front of the absolute value sign, if it's positive, in this case positive 1, the absolute value would open up. And that would be the graph for the function. Last question for this section. H of x equals the absolute value of 3x minus 1. And again, to graph this using just a single point, we'll take what's inside the absolute value sign, in this case 3x minus 1, and we'll set that equal to 0. Solving, we can add 1 to both sides and divide by 3. So x is equal to 1/3. And again, to graph this, we'll do a single point on a xy t-chart. 1/3 will be the only x value that we have to use. Plugging 1/3 in, 3 times 1/3 would be 1, and 1 minus 1 would be 0. Graphing this single point, 1/3 for x, and y value of 0. Again, looking at the number in front of the absolute value, as long as the absolute value is positive on the outside, the absolute value graph will point up. If there's ever a negative outside the absolute value sign, then it'd be the same graph but pointing down. Title of the first section today is Graphing Inequalities. In this section, we'll graph inequalities on the xy axis. First question is 2x plus 3y less than 6. There is a few ways to graph this equation on the xy axis. One way, since this inequality is in standard form, where we have x and y on the same side, we can find the x and y intercepts. To find the x and y intercepts, we can plug a 0 in for x. 2 times 0 would cross off, so we'll have 3y is greater than 6. If we divide by 3, we'll have y is greater than 2. So the y-intercept in this case would be 2. Solving the same question, if we put a 0 for y, so 2x times 3 times 0 is greater than 6. Again, 3 times 0 would cancel. 2x is greater than 6, we can divide by 2. And we'll have x is greater than 3. These are the intercepts. So if we draw a xy axis graph, on the y-axis, the y-intercept would be 2. And on the x-axis, the x-intercept would be 3. Normally you can connect these to make a straight line for the graph. The original equation, though, is greater than 6. If it was greater than or equal to, it would be a solid line. Since it's just greater than and not equal to, it will be a dashed line going through the points. And the last part for inequality graphs is shading. We'll either shade above the line or below the line. To figure out which way to shade, one way is to use a test point. A test point is picking a point on the graph, plugging it into the original question to see if it works. The easiest test point to use is 0, 0. So we can plug 0, 0 into the original question. If 0, 0 works, we'll shade the side that has 0, 0 on it. If 0, 0 does not work, we'll shade the opposite side of the line that does not contain 0, 0. The original question was 2 times x, or 2 times 0, plus 3 times y, or 3 times 0, is greater than 6.